portrait of engine watch keeping. So today's video, we're talking about
Good day everyone, I am Engine Cadet Dave Jan Generosa and I am here to discuss with you or to know about how does air compressor works. Okay, how does air compressor works? Air compressor works by forcing atmospheric air under pressure to create potential energy that can be stored in a tank for a later use. Just like an open balloon, the pressure builds up when the compressed air is deliberately compressed or released, converting the potential energy into a kinetic energy. From there, this energy transfer can be harnessed to power various pneumatic tools. Industrial air compressors work similarly to combustion engine. Generally, air compressor operation requires a pump, cylinder, piston, crankshaft to transfer energy for a wide variety of tasks. These basic components can help supply air filling up objects like inflatable tool, tires, or etc.
Engine Cadet lesson. My report is types of air compressors. And there are 4 types of air compressors. First, rotary screw compressors. Rotary screw compressors have gained popularity and market share. Compared to reciprocating compressors, since the 1980s, these units are most commonly used in sizes ranging from about 5 to 900 HP. Second, reciprocating compressors. Reciprocating compressors have a piston that is driven through a crankshaft and by electric motor. Reciprocating compressors for general purpose use are commercially obtainable in sizes from less than 1 HP to about 30 HP. Third, vane compressors. A rotary vane compressors use an elliptical slatted rotor situated with a cylinder. The rotor has slots along its length. Each slot contains a vane. Fourth, compressors motors. Electric motors are widely used to provide the power to drive compressors. As a prime mover, tutor need to supply sufficient power to start the compressors, accelerate full speed, and keep the unit operating under various design conditions.
The main function or purpose of compressed air system on board ship. Control air plays a vital role in propulsion of ship and it's used for controlling the function of ship engines including ship's engine speed, direction of running, starting, stopping, reversing. The engine room of the ship is the power plant of the vessel and vital for its operation. There are many uses of control air engine room, which is widely known as the heart of the ship. Most of the pipelines in engine room are fitted with valves.
Steam is a necessary ingredient on board ship, and boiler in the engine room generates steam to heat the engine fuel, water, and air. Control air is used to provide signals to these boilers during their operation. As you will remember from the study about types of propellers on the ship, a propeller is basically a fan which rotates to move the ship. This propeller is driven by main engine of the ship via a shaft which are conducting outside into the water from the ship. This penetration is sealed through combination of seals and control air, thus preventing the open sea coming into the engine room of the ship. Last but not the least, on small ship, engine and propeller shaft are coupled with clutch and control air. It's used for clutch in and out operation, thus providing wonderful control of ship.
Good practices for safe and efficient operation of air compressors on ships. Check oil level in sump. Record the amount top up. Do not overfill. Excessive oil consumption or pressure buildup in the crankcase to be observed. Investigated and rectified as soon as possible. Drain oil air bottles regularly. Ensure air to deck. Service air is shut down when not in use. Give attention to any air leakages reported and rectified. Daily record running hours and log it. Daily check automatic drains and unload of air compressor for proper functioning. Weekly check the operation of the relief valves connected to the LP, HP stages by operating manually.
Every air compressor on a ship is fitted with several safety features to avoid abnormal and dangerous operational errors of the equipment. If safety alarms and trips are not present on the air compressor, abnormal operation may lead to breakdown of the compressor and may also injure a person working on or around it.
Diesel engines are started by supplying compressed air into the cylinder in the appropriate sequence for the required direction. A supply of compressed air is to stored air reservoirs or bottles ready for immediate use. Up to 12 starts are possible with the stored quantity of compressed air. The starting air system usually has interlocks to prevent starting if everything is not in order.
A starting air system is shown in this figure. Compressed air is supplied by air compressors to the air receivers. The compressed air is then supplied by a large bore pipe to a remote operating non-return or automatic valve and then to the cylinder air start valve. Opening of the cylinder air start valve will admit compressed air into the cylinder.